Hi guys, welcome to the fractional distillation lab tutorial. Before we get into the specifics of fractional distillation, let's talk in general about what it is. This is a separation technique that is mostly used to separate a mixture of liquids. So let's create an imaginary liquid. Let's call this mixture just half alcohol, half water. And we use ethanol, that's a type of alcohol, for our alcohol burner. So let's say that we mix those two things together, and it would look nice and clear if we did that. You wouldn't be able to, the two things would not separate, even though they have different densities. They're what we call miscible liquids, which means that one dissolves in the other. And so it would be a perfectly evenly mixed mixture of ethanol and water, would be a solution. And so the only way we could get them apart after that would be to use their boiling points. Alcohol boils around 80 degrees, a little bit below 80 degrees. Water boils around 100 degrees. So if I were to heat this over an alcohol burner and measure the temperature every 30 seconds or so, I would get a double plateau graph that looks like the one you see here, because I would get a plateau when the ethanol is boiling, and I'd get another plateau when the water's boiling. Now, if I'm creative, I can set this up so that I can capture the liquids as they turn to a gas. So here's how we're going to do that. We're going to use one of those glass bends, and we're going to hook it to some tubing and make the whole system go off to a test tube so that we can collect what we call the distillate. Distillate is a liquid that you boiled away and then recondensed into a liquid. Here's what that looks like. Okay, so follow along in your lab sheets. So we are in the first box where it says read the procedures below, and the boxes to the right answer the related questions. You want to make a rough sketch, fairly neat, of this setup in the box to the right that's across from numbers 1, 2, and 3. So you're going to set up the distillation apparatus like this. Let me just tell you what everything is, right? So you have a large test tube. So this is a large test tube right there, large test tube. And it's in a large clamp. And you've got a fire stand right here. And an alcohol burner. And up here you have this is actually a number 4 2-hole stopper. You can just call it a stopper. Number 4 is the size, and 2 holes is how many holes it has in it. It has 2 holes because you need to have a temperature probe in one hole, acting as your thermometer. And you'll notice that the temperature probe ends somewhere around here. It's not actually in the liquid. It's actually measuring the temperature of the gases. And then you also have this glass bend up here. And attached to the glass bend is what we call delivery tubing. In your lab sheets, I used to have black delivery tubing, now I don't, so it might refer to it as black. It's now white. And then over here we have another large test tube. You can use small test tubes if you prefer, or if there aren't any more large ones. And then depending if you use a large or a small test tube, you're going to need to clamp that in place with either a large or small clamp. And then we have a beaker and a water bath. The water should be from the sink, nice and cold. And it should be about 3/4 full. Off screen, hard to see, I have right here a test tube rack. And in that test tube rack, there's going to be 2 other test tubes, large. Because we're going to separate our liquid into different fractions. This is why it's called fractional distillation, because what you're trying to do is take the whole apart into its individual fractions that make it up. So in the previous example, we were just going to do water and alcohol. And if we just have 2 liquids, then you only need 1 test tube to collect 1 liquid, and the test tube you're starting with will hold the other one, so you don't really need very many test tubes. But if you have a more complex mixture, you need lots of test tubes to hold all of your different items. Let's clear the screen and focus on the next step in the lab sheet. So you should draw this picture and label it in that little space. I know it's little. If it makes you feel better, if you hate writing in little spaces, you could just write C back and then write it on the back of your lab sheet. Now, I've cleared the screen so that we can talk about the next few steps. So in number 4, it tells you to set up your lab quest the way that you're directed to. So you're just going to put the rate in as 2 samples per minute. So every 30 seconds, it's going to record temperature. And you're going to set it up to record data for 20 minutes. Then it's a good idea if you want to keep the graph of this data, you can actually get it to show up on your iPad if you connect to that graphical analysis app that you have. If you don't remember how to do this or if you're having trouble doing it, you can let me know and I'll help you with it. You don't actually need to do that step because I'm not asking you for the graph, but if you want to have it as part of your data, then you need to set it up so you can get it on your iPad. In number 6, it tells you to clamp a small test tube of cabbage juice indicator to the pegboard so that you can watch for a color change as you bubble gas through it. What's going on here? Well, I'll tell you. Our soda, our cherry Coke, actually has carbon dioxide gas in it, and we're going to, instead of collecting that gas, we're just going to note that it is there, and the way we're going to tell that it's there is we're going to use that carbon dioxide gas to change the pH of an indicator. We've done this before with phenolphthalein. That's the liquid that turns pink or white depending if it's an acid or a base. I'm going to give you a new indicator that's cheaper and less dangerous than the phenolphthalein. It's made with cabbage, red cabbage, so I boil up some cabbage. The whole room's going to stink, I apologize. And then I grind it up in my food processor, and then I strain it, and then you get this nice purple liquid, which you will put into a small test tube right here. And you'll fill it up to about here. And what you're going to do is you don't even need it in the water bath. You can just have it hanging out above. And what you're going to do is when we get ready to collect the carbon dioxide, when we know the carbon dioxide is bubbling out of our liquid, which it will do when it gets hot, right? As soon as we do that, we'll put this end of the collection tube into that test tube with the indicator, and you'll notice that as the pH changes, the color will change of your cabbage juice. It's kind of a cool little experiment. You could also make this happen by blowing into it with a straw, and you can do that as well if you'd like to, as long as you don't want to suck up the cabbage juice, because I'm sure it doesn't taste particularly good. But if you blow into it, the carbon dioxide from your breath will also change the color of your cabbage juice. But before we even do this, before we even check to see that we have carbon dioxide gas, which we probably already know that we do, we're going to actually check for the cherry flavoring, which comes out a little bit before or around the same time as our carbon dioxide gas. But I get ahead of myself. So we're in number 6, so we're just going to get set up. We're going to put our cabbage juice over here so that when we're ready, we'll be able to bubble through it. But the next step is to add 5 milliliters of cherry Coke to our large test tube. And we're going to drop in, you see these little white stones here? You're going to drop 3 stones. They're called boiling stones, or sometimes they're called boiling chips. What they do is they actually attract bubbles to them so that as you boil your liquid, sometimes boiling can be very violent, especially when you have a small amount of liquid. And so if the bubbling gets too violent, your test tube will actually knock around and jump right out of your clamp. By the way, if that happens, don't try to catch the hot test tube that's flying out of the clamp. That will cause a serious burn. Just let it go flying if that should happen. But it probably shouldn't, especially if you use the boiling chips. What the boiling chips do, or the boiling stones do, is because they collect bubbles on their surface, they reduce the amount of bubble popping that happens below the surface of your liquid. And that allows your liquid to boil more gently or less violently, which is much safer. So now, after you've got it all set up, in number 8, you're going to begin heating your soda with the alcohol burner. You're going to hit your green hour on your iPad so you can collect your data. And what you want to do is you want to actually hold the end of this white tube, your collection tube, in your hand. Don't put it in your test tube yet. Don't put it in your cabbage indicator yet. Hold it in your hand near your nose, not up your nose, but near your nose, about an inch away from your nose, so that you can smell when the cherry flavoring escapes. Your cherry flavoring is actually very, very, very easy to turn to a gas. It's a liquid, but it has a very short plateau. It's hard to capture the plateau temperature of your cherry flavoring because there's not very much of it, and it tends to escape really, really quickly. So instead of figuring out when our cherry Coke flavoring is boiling by looking at our plateau, we're going to figure it out by waiting to smell it. So as soon as you smell that cherry flavoring, you're going to record the temperature that you smelled it at, and then you're going to insert that white tube into your cabbage juice indicator. So this tube you'll then insert here. Now, on the next page, number 10, it's asking you, why does the indicator change color? That's because the pH is going to change, because carbon dioxide actually will make your soda a little bit acidic. So the carbon dioxide, when it dissolves in a liquid, makes the liquid acidic. And you want to compare the color of the indicator juice to some control juice that I have set up in the front of the room. And that will let you know what it looks like when the pH is different levels. So you'll be able to tell exactly what pH you have. Then, number 12, watch your graph forming on the LabQuest. There's going to be a plateau that's going to form somewhere around 97 to 99 degrees. That's your water boiling. That should boil for a while, 5 or 10 minutes depending. And during this phase, you'll see that your water will turn to a gas. You won't see the gas. And that it'll sort of like, you'll see it bubbling furiously down here. And then you'll start to see little droplets of water maybe up here as it turns back into a liquid when it gets away from the alcohol burner. So that liquid will then drain down into your test tube. You want to be collecting into a new test tube. So after you get all your carbon dioxide gas out, that's around 60 degrees, you're going to pull your cabbage juice indicator out and you're going to replace it with an empty test tube that's going to be submerged in the water bath. It's in the water bath so that it keeps that newly forming liquid nice and cold, because remember, it was just a gas. It's really hot, so it has a tendency to go back to being a gas if you don't keep it cool. So you're going to be collecting water in here. And the majority of your soda is water. So you're going to boil it until your plateau breaks. When you see that your plateau makes a significant break, I mean, it's going to go up and down. You know, you're not going to be exactly 99 for forever. It's going to probably be 99, 100, 97, 100, up and down like that. But when you start to feel like, you know what, I'm pretty sure this plateau is done. It's like 102 now. Then it's time to remove the white tube from your collection tube. It's very important that you remove that tube before you blow out your flame because of suck back, because the pressure will drop in your test tube over here when the temperature goes down. And if that pressure drops, then the liquid that this tube is dangling in will get sucked back up, and you don't want that. You just spent all that time boiling it away. So remove that white tube, drape it over the back of your pegboard, let it drip, don't worry about it, not a big deal, and then blow out your flame and let everything cool. Here's the deal. You should have a little bit of a sort of brownish liquid left in here. That's your food coloring, the syrup coloring that goes with, and it also has your sugar dissolved in it, right? So does a lot of sugar. Now here's the trick. If you heat this, if you miss your plateau breaking and you overheat the remaining liquid, this liquid in here will be water, it'll be nice and clear. But if you overheat this one over here, it will burn the sugar, which not only smells terrible, but ruins my test tube and ruins your experiment because you can't get the density of burnt sugar. What you want is to keep that sugar dissolved in a little bit of liquid. It's really in the form of high fructose corn syrup, so it's a syrup that you're going to get, but it will burn. It will burn shortly after your water is all boiled away, so you got to keep your eye on it. When you start to feel like you're getting down to the point where, gee, I don't know, it's kind of a pretty concentrated syrup-looking thing down there, you're done. You don't want to overheat that. You don't want to burn it. If you do, what that means is you'll have to get some more soda and try it again. But it's not a big deal if that happens to you. Now, once you're at that stage, you're going to let everything cool down and you're going to want to find the density of the two different liquids. The water should have a density close to 1. It should be fairly pure. To find density, you got to follow the directions really carefully, because when you find the density of a liquid, you have to think about you have to get rid of the mass of your container. And you want the container that you mass in to be a graduated cylinder, because as soon as you start pouring a liquid from one container to another, you're going to leave some behind. So you don't want to get the mass of your liquid in one container and then pour it into a graduated cylinder, because that will leave some liquid behind and you won't get an accurate density. You want to use a small graduated cylinder and a small amount of liquid, because that way you'll be able to do this on the electronic balance. So read the directions carefully, make sure that you understand how to get the density of your liquid. And then after your liquids have cooled off and you've gotten their densities and you've filled out your data table, what you can do then is you can actually look at your chart on the next page. So we have 16, 17, number 18 says return the lab setup to the condition you found it in, clean the marbles. There's no marbles in this lab. I used to use marbles instead of boiling chips. Long story, didn't work very well. So you're not going to clean the marbles, but you are going to clean your test tubes. And if the test tube is not coming clean, see me and I'll either replace it or tell you that, gee, you should use soap. And then you're going to fill in that data table down there with the different fractions. Notice that fraction 1 was your carbon dioxide. And notice how I put X's through the data table because you can't find the boiling plateau of your carbon dioxide. It's already boiled. It's a gas. So you can't get its mass, its volume, its density. It doesn't have an odor. It doesn't have a color. But you can tell its pH by using the cabbage indicator. And then you're going to indicate its identity. And then fraction 2 is actually going to be your cherry Coke flavoring, the cherry flavoring. Again, your plateau, you measured that by when you smelled it is going to be your plateau temperature, but you can't get the mass, volume, and density of it. You can record the odor, doesn't have any color, can't get pH. So you can put X's for those things for fraction 2. Fraction 3 is going to be your water. You can get all of this information for your water, and I'll show you how to get the pH of your water as well. And then for number 4, you're going to get that's your corn syrup or your sugar water, your syrup that's left in your other test tube, and you should be able to get the boiling plateau for that. It'll be a short plateau, the mass, the volume, and then the density. You can smell it, see if it has a smell, write down its color, and I'll show you how to get the pH of that as well. Okay, then look at the conclusions, and you're going to need to answer the conclusion questions. Don't skimp on this part, because that is where the majority of the grade comes from. And I'll probably talk about that in class because this tutorial is long, man. So that's it. I'm done. And hopefully you guys will be able to watch this in class and then at home and in parts and not get overwhelmed with how long it is. But hopefully you'll find it helpful. And I'll see you guys in class.